as we get ourselves ready for getting into decision analysis and really more the decisions about data, what do they mean? Do we really, if we have two different processes at work, do we really have significant differences there? Can we make conclusions that are somehow validated by statistical measures, numerical quantities? As we head towards that, we're going to first start with a segment on descriptive statistics, and then we're going to get into some confidence intervals, parameter estimation, that sort of thing. And in particular, this module will be talking about descriptive statistics and parameter estimates. And we're going to motivate this by taking a look at some actual data that I've labeled as example DS 1.1. It's actually data taken from an exercise 6-23 of the Montgomery and Runger text, where we have 70 different aluminum test coupons that have been subjected to repeating alternating stress cycles of 21 KSI. It turns out that those stress cycles are happening at 18 cycles per second, or 18 hertz. That's not particularly significant for how we're going to be looking at this data, but for those who are very much into this sort of thing, the speed at which, or the rate at which you do the alternating will have an influence on the data that you actually end up gathering. That's another one of what you could say is joint information as a part of this kind of test. And you see a lot of numbers there, and they are the numbers represent the number of cycles to failure. So it's a little bit like a fatigue type problem. I say a little bit like because it'd be quite low cycle here. Again, high cycle fatigue is on the order of thousands and thousands of cycles. This is low cycle fatigue, down around 1,000 or so. There are a number of questions that we might want to ask here as we try to get some kind of sense of what this data is all about. And those questions in the broad view are of the nature of how to summarize or make sense of all this data that we have. Sometimes we have just a little bit of it, other times we have so much of it that we got to figure out some way to answer what do the data mean, and is there a representative number or some sort of representative measure that somehow characterizes the data set. A bit like trying to somehow simply characterize an individual person with just one adjective is pretty difficult, and the same is true with data as well. Right? And in a sense, what we're really doing is it's a form of data reduction. That is, trying to simplify this down to something to its critical kernels of truth, so to speak. And the answers that we're going to develop are going to come from a variety of tools. Those tools are going to tend to be either quantitative in nature or graphical in nature. And these tools put together are what give us our descriptive statistics. What we do with those statistics is the next series of modules that we'll be going after. Right? So under quantitative, the typical kinds of things that we're looking for here are measures of a variety of different things, one of them being central tendency. Certainly the sample mean would be one of those, the average. But there are other measures of central tendency, and we already know that there are ways to measure spread or dispersion in populations, and here for this subset of a population, this smaller sample set, then we're going to go after measures of dispersion or spread. We're also going to be interested in any asymmetry that might be present in the data, as well as this funny thing that we'll call peakedness, or multimodality is a more formal kind of thing, multimodality, and that'll become more apparent when we get to that point. That's our basic essence of what we're going to go after in terms of descriptive statistics on the quantitative side. On the graphical side, there's a whole variety of different ways we might look at the data. Some of these are quite simple and you've seen them before in your own life. There's scatter plots, particularly if this is data related with a time series. And especially if we're saying, looking at the length that a part produces, or excuse me, a length of a part that a machine produces, and we're looking at that over time to see if there's any drift that's happening in the machine. There's also histograms. You've almost certainly seen those. We've talked about them in this course already a little bit. There's a clever device called the stem and leaf plot. Not used as much anymore, but it is a really nice, simple, elegant, easy to create, although sometimes time consuming for a large data set. But there's a lot of interesting information from a qualitative standpoint that you can get out of a stem and leaf plot. A similar plot is called the dot plot that goes along with the stem and leaf plot, and these are going to look very much like the histograms will look like. There are also box plots. You see those in quality control kinds of environments. And then there is the probability paper plot. And we've talked about that briefly before, and we'll return to that as well. Okay. And again, the big key here is that these tools not only will summarize our data, both in a quantitative sense and a graphical sense, and give us some kind of meaning to that big long set of data that we have, for instance, what we just saw previously, but they also are going to provide the means, put that in quotes, for our probability models. In particular, what they're going to do is enable us to make parameter estimations. And that's true whether we are interested in trying to predict the future or whether we're just trying to simply analyze the data set that we have.
this classic car, the massively successful, cheaply successful, inspectable Steve was making a nice little tour around the strip and perhaps one of the most famous Mark II drivers. So what were you just talking about? Well, you're driving. You've got zero in your hand. I was tapping out the international distress call. Play our song. That's all it. Thank you very much. Beautiful Mark II Jaguar in all the right places. And the good news is, it's created a bit of a buzz. Now this chap behind me is called Dave, and I think he's pretty serious. He's travelled overnight from the north of England, and guess what? He brought a trailer with him. Now let's see if I can put a deal together. So then Dave, what do you think?
It's beautiful, mate. Lovely leather, the wood, the colour. Really
I'm glad you like it too. We spent quite a bit of time in there getting it just right. We've changed the wood, we've changed the leather on the seats, and I'll tell you what, it's transformed the interior and it's given it a new lease of life. So the question is, do you want to buy it?
I want to buy it, mate. If the price is right.
Well, the price is always right as far as I'm concerned. I've advertised it for £10,000, and I think it's worth every penny of that money, because where you go with this car, it's going to bring you joy.
It would give me a lot more joy if I could have it for £8,500.
£8,500,
Yeah, that is not even cheap, is it?
I could let go for that, because it's such a nice car. I've reduced it down to £9,500 for you. How does that sound?
9 is above the limit. I would have liked the mechanic to come along and have a look at it, just to put my mind a bit. With that in mind, I was prepared to push myself to 9,000.
Yeah, I can understand that, but trust me, this is a good car. If anything goes wrong with it, you can bring it back here, and I'll get my mechanic to sort it out for you. And I will accept your offer. Is that a deal? Deal. Top work.
Thank you.
Well, it was lucky I sealed that deal, because the rain came in seconds after we shook on it. But I'm not letting it dampen my mood, because me and Ed have landed a credible £1,100.